Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you're going to do remove, replace, reduce. Remove the 7 by multiplying it by the 2, and you'll have x squared plus 9x plus 14. When you factor it, you'll replace your 7. You have x plus 7 and 7x plus 2. The first one will reduce to x plus 1 and 7x plus 2. And so that will be your answer. For the math knowledge question, what is the measure of the acute angle where First Street intersects South Street? So they have right here. So they tell us that north and south are parallel, and first and second are also parallel. So this is basically a parallelogram. So if this is 55 degrees, this angle here is going to be 125. So this angle here is going to be 125 because opposite angles are congruent on a parallelogram. And so if this is 125, this angle here is going to be 55 degrees. So that'll be your answer. Okay, so we're looking at lesson 32 today. We're looking at an antiderivative, and then we're going to look at indefinite integral. So hopefully you'll understand what the antiderivative is even talking about, and you'll understand what the indefinite integral is. So the inverse operation of differentiation is going back to the original function, and that's called antidifferentiation. So we've talked about taking derivatives, and differentials are a type of derivative where you have to do the dy or the dt or whatever. So antidifferentiation is going back to the original function. So if we have a function x squared and we want to take the derivative of that, the derivative is 2x. We have been doing that. The derivative of x squared plus 42 is also 2x. The derivative of x squared minus 165 is also 2x. All of those have the same derivative. So no single function is going to be the antiderivative of 2x because there are infinitely many functions whose derivatives are 2x. You have x squared, and then plus or minus any number is still going to be, when you take the derivative, 2x. Okay, so we have a function f of x equals 2x. And we want to find the function capital F that is an antiderivative of f. So find a function that is the antiderivative of f. So what are we going to do to find the antiderivative? Well, when you take the derivative of something, what gives you a 2x? So this was our formula. I shouldn't write in green on this background. So we need to move that in back up here. And so if you use your original function, you should get x squared. And if you check, move the 2 in front, 2 minus 1 is 1, and you get 2x. But it says that is an antiderivative of f. So just pick a number. The book picks negative 463. I'm going to pick 1,000,000. There's my answer. This here can be any number. It does not matter. You just have to have x squared and then plus or minus some number. So normally when they're talking about antiderivatives, what they're going to do, x squared plus c, where c is some constant to represent that it can be any number. So that's how we normally are going to do antiderivatives. So now we're going to look at indefinite integrals. So indefinite integration is the process of finding the set of all antiderivatives of a given function. So you're not going to have one particular answer. You're going to be finding all of the antiderivatives. Okay? So antiderivatives and indefinite integrals are pretty closely related, except for when you find an antiderivative, you're just putting a number in, And when you do indefinite integrals, you're going to use that c that I just mentioned. So we call the set the indefinite integral. It is incorrect to speak of the antiderivative because there's more than one. So you could find an antiderivative, but you can't find the antiderivative. However, you can speak of the indefinite integral because it is a set of all of your answers. So you have one indefinite integral for your function. So this little symbol here is the integral symbol. This is how I write it. Well, maybe not like that. I write it like that. And then 2x plus dx. So we are integrating with respect to a variable of x. And so the integral of 2x is going to be x squared and then plus some real number. We don't know what it is. It could be 0. We don't know. And so we use a c to represent any real number, and we call the c the constant of integration. So one thing to note, on your test, when you start having these, and it says integrate 2x dx, if you put x squared as your answer, I'm going to put minus 1. You have to remember to put the plus c. So you don't get the question wrong. So you don't lose all of your points, but you just lose 1 point, and you can't earn it back. So if that's the only thing you miss on your test, you will join many other students who make a 99 on their calculus test instead of a 100, just because of that plus c. So you do have to make sure to get in the habit of putting it. Alright, so finding the indefinite integral of a function requires the ability to guess the answer based on experience with derivatives and differentials. So as you do these, you'll get better at guessing them, but sometimes people take a little bit to be able to get better at guessing them, and that's okay. So we can check our guess by just taking the derivative or the differential to see if it's what we started with. So we want to find the integral of cosine of x with respect to x. So we know that the derivative of sine and cosine are closely related to each other. So I'm just going to pick sine. What is the derivative of sine? The derivative of sine is cosine, which is what I have right here. So the integration of cosine goes to sine, and then we put our plus c, and that is our answer. Okay, so now let's try another one. The derivative of negative sine of t. So again, I know that sine and cosine are related. They go back and forth. So I'm just going to pick the cosine of t. Now let's check. What is the derivative of the cosine of t? The derivative of cosine of t is negative sine of t, which is what I have right here. So this is the correct guess. And then you have to put plus c to finish it out. Okay, so that's how that works. Let's look at another one. We want to integrate e to the x dx. So what is the integration of e to the x? What do y'all think? Hopefully you're guessing maybe just e to the x, because what is the derivative of e to the x? Just e to the x. And so that's what we started with. So we put plus c, and there's your answer. Okay, so now we have another one. The derivative is cosine of x, and we want to find y. So they gave us the derivative, and we need to find the original function. Basically, we want to integrate the cosine of x. What do y'all think it might be? Sine and cosine go back and forth, so if you integrate cosine, you should get to sine. And the derivative of sine is cosine, so that is correct. And we put plus c and move on. Okay, so that's how those work. Your homework tonight, you do get to omit number 16, because that says to develop identities for your half-angle identities, and we're not doing those. And then we're omitting number 25, because that's dealing with geometric sequences. So do the rest of those tonight so we can go over any questions you have tomorrow.